GMAT all day.
One reason that I think people tend to like overlapping set questions is that they are very recognizable. They sort of have their own rhythm to them that your brain can pick up on subconsciously and say, oh, this is an overlapping set question. And that really is the most important part of an overlapping set question, just recognizing when you have one. Because once you recognize that you have an overlapping set question, you can sort of set them up the same way every single time. And so I think one of the ways people can get into trouble with overlapping set questions is when they see a question that seems like it could be an overlapping set question or could be framed as an overlapping set question, but they're not sure exactly. And because they're unable to articulate exactly what makes something an overlapping set question, they either set it up wrong or they have to think of a different way of approaching it altogether. And so let's talk about what exactly makes something an overlapping set question. Because again, I don't think of the approach to overlapping set questions as being the gospel way of doing them. All it is, setting up your information in a table or a matrix is a way of organizing information. And so if you think about it that way, what you are looking for is you're looking for a scenario that fits this acronym, which some of you may have heard before. It's called MEAS. And so I know this is an acronym that is popular in the business and consulting worlds. I'm not sure exactly why, because I've never seen a scenario where it's really applicable except with overlapping set questions on the GMAT. So if you end up going to business school and you find out how this is used in the real world, you can let me know. But what MEAS stands for is mutually exclusive, collectively exhaustive. And so this is the sort of scenario you are looking for in order to determine whether something meets the criteria to be an overlapping set question, mutually exclusive, collectively exhaustive. And so the best way to probably explain what type of scenario this is with an example. So let's look at an overlapping set question. 6,500 people participated in a study measuring the correlation between gender and cancer risk. How many of the females in the study were not at increased risk of cancer or for cancer? And so this is a very typical sounding overlapping set question. And so the way I organize my information for overlapping sets is once I recognize that I have one, I make a table and I make the headings first. And so you're looking for a scenario where you have two groups. So in this case, the two groups, you can think of it as gender and cancer risk. And then within those two groups, there's sort of a binary option. So for gender, in this case, the GMAT, as far as I know, still only has two genders on it. But you could say within gender, you could be female, and I wouldn't even put male yet. I'll say not female. I'll explain in a second. And then for cancer risk, there's also two options. You can either be at increased risk for cancer or no increased risk for cancer. So those are our two groups, and each with a binary option. And between the two options within each group, you have a situation that is mutually exclusive, collectively exhaustive. In other words, your gender is mutually exclusive. Every single person is either female or not female, and there's no overlap between those two people. You can only be one or the other. Just like you can only be at increased risk for cancer or not at increased risk for cancer. You cannot be in both groups. Both options are also collectively exhaustive, meaning between your two choices, every single person in your sample or your population is represented. So every single person in our study either is female or not female. So this is in fact why I'll sometimes, instead of writing female, male, I'll write female, not female, because I'm trying to make sure that I have a mutually exclusive, collectively exhaustive situation. And so by saying not female at first, I'm ensuring that every other person in my study is represented here. And so once I have it as not female, and then I see that it fits the criteria, I can say, okay, not female means male. And then the same for cancer risk. And so it is collectively exhaustive. Every single person in your study either is at increased risk for cancer or is not at increased risk for cancer. And so once you have your table set up, each of your boxes here should represent the number of people that fits into that intersecting group. So here would be females at increased risk for cancer. Here would be males at increased risk for cancer. And again, just like with your categories themselves, there is no overlap between your boxes. And it's also true that when you sum up your boxes, you have all the people in your study. So nobody is double counted, and likewise, nobody is left out either. And so then your rows and columns at the ends here are sort of your subtotals. So this here would be your total females, total males. This box here would be total people in the study, total increased risk for cancer, total no, not at increased risk for cancer, total increased risk for cancer. So once you have your table set up, then it's sort of just like you just got to fill it in with the information they give you. And so the one thing to keep in mind, one thing that makes overlapping set questions tricky is on data sufficiency questions, because you have to keep track of your information and remember which statement it comes from. Because if I have to, I'll redraw a fresh grid for each of the two statements. But probably don't want to be doing that because it takes up time and space as well. So what I do is for the prompt, any information that comes from the prompt, meaning it's universal, it applies to both statements, I'll circle in my grid so I know not to erase it. So 6,500 people in the study. So that's total people. Give myself a participated in a study measuring correlation between gender and cancer risk. How many of the females in the study were not at increased risk for cancer? So we want females not at increased risk for cancer. So that is this box here. And I can say this is my X. This is what I'm looking for, which is also something you would want to highlight. Keep in mind what the question is you're trying to answer. And so now I just have to make sure it's data sufficiency. So I don't actually have to calculate the number of people in this each group. I just have to know that I can calculate a box, and I need to know I can calculate enough of the boxes to get this box over here. So statement 1 says of the 3,200 males that participated in the study, 2% were found to be at increased risk for cancer. So let's break this down. So of the 3,200 males, so they're telling us that there are 3,200 males in the study. And so since this comes from statement 1, I'll put a little 1 in the corner here. So I know that I have to ignore this for when I look at statement 2. And so based on this, then you could also say, oh, from this I can infer there's 3,200 males in the study. There's got to be 3,300 females in the study, because my males plus my females, they are collectively exhaustive. So they must sum up to my total. Of the 3,200 males in the study, 2% were found to be at increased risk for cancer. So we know this box here is 0.02 times 3,200. And like I said, I don't have to actually calculate what this is. And I don't want to actually do the arithmetic here unless I have to. And so because it's data sufficiency, for now I don't have to. So 2% of the males were at increased risk. That also means 0.98 or 98% were not at increased risk. So this box here should be 0.98 times 3,200. There's still not enough, it looks like, to get this box here, though, because I would need this box here or this box here, which I cannot get. So statement 1 by itself will be insufficient. Statement 2, 3,300 females participated in the study. So if I, for a second, pretend that I don't have all this information, and now all I know is this, I have 3,300 females that participated in my study. Well, right off the bat, you should sort of know that this is not only going to be an insufficient statement, it's going to be an irrelevant statement. It's not contributing anything, because even though they didn't tell us this in statement 1, we were able to infer it. And so this information is stuff we already knew in statement 1, and it wasn't sufficient then. There's no way it's going to be sufficient now. And you can, based on that, eliminate both B and C, because you know it's not going to make the statement sufficient together. It's not going to become sufficient when you add this information to statement 1, because it's just restating information we already knew from statement 1. And so based on that, E is going to be the answer here. And so that is an intro to a fairly simple overlapping set question. I feel like the GMAT test writers are trying to make them a little bit more complicated because they think people sort of have hacked them in recent years. So we will do some complicated ones and show sort of some twists that they like to throw in. But overall, this is the basic setup that I use for pretty much any overlapping set question.